Hello and welcome to this video on rootstock, why it is used and how. If you buy any tree or similar from a nursery, there's a very good chance it'll be on rootstock. You can tell if this is the case by looking at the bottom of the trunk. If there is a graft junction visible, it's a tree that is being grafted to rootstock. And obviously, if this is missing, it's not the case, but for the vast majority of nursery stock trees, particularly fruiting trees, this will be true. If there is a graft junction visible, it's a tree that's been grafted on rootstock, but this is common not just for quick tree creation, but also to create trees that dwarf or otherwise are better suited to certain conditions. Another reason is simply that fruit trees grown from seed may not be true to nature and therefore give you a different tree than that from which it was spawned. Grafting mitigates this issue as you can take a branch from one tree, which ensures true form and continuity as it is literally a clone of the original tree. A rootstock, as the name would suggest, pun intended, is a type of tree grown not for its trunk and branches, but for its roots. It's used as the material onto which more desirable trees are grafted to give them specific traits or to control their growth. It is as named for the most part the roots of the tree, but typically there is a short section of trunk also present. This can be as little as a few centimeters, or about an inch, all the way up to tens of centimeters or several inches in length at a time. The trunk portion primarily exists not so much as a trunk in its own right, so much as a place to graft the scion onto or into. What is important with rootstock is the namesake material, the roots. These are partly what will give it all the desired features, and it's why it's used. For this video we can look at several features of rootstock and how they are used, but particularly focusing on size reduction and local condition accommodation. The first thing is how they get the rootstock, and the answer is something very similar to a raft bonsai. It is a tree from which the rootstock is grown that gets laid down onto its side for the new shoots that were previously branches to grow up as a sort of trunk. These are cut out and free to form a new rootstock which can be used. The advantages to this is that each rootstock harvested is not only clean, but it's also genetically identical to the original. That means they will always have the same strengths and arguably weaknesses of the original. There are common varieties used for dwarfing rootstock, but for now we'll focus on apple as an example. The common apple rootstocks known today include your M9, M27, M26, MM106, and MM111. And yes, these do sound like American things because that's basically where they come from. It's American government standardization in naming, let's say, and not sadly a bazooka, tank, or similar. Why we specifically call out apple trees is that they are an example, and it's true that a lot of different fruit trees have their own variety of rootstock, so at times you may need to be very careful in your selection as not all species of rootstock are compatible with another species. For example, the examples we have for an apple may not work for something like a pear or something else, and that means you need to choose the right rootstock for the right species that you're grafting it to, or inversely, you're grafting to the rootstock. Next we have why you might use it, and well, simply put, you're looking at different conditions, for example soil conditions. Some soil conditions are just not really hospitable for life. If you go into the middle of nowhere, and for example a desert, there really isn't much water, so you may want to try and find something that's going to accommodate a very low water environment. Admittedly, you're probably not going to be growing fruit there, but as an example. There are, however, more practical scenarios. For example, somewhere that's got a much more clay-rich soil. Clay holds onto water to some extent, and it's often very mineral-rich. In other cases, it might be something that's very saline because it's, say, near an ocean. The choice of rootstock is what's going to help your trees grow better in that particular environment. It's also going to ensure they can get the nutrition they need and, well, unsurprisingly, grow. On top of all of this, rootstock can be used to mitigate things like water. Now, we're not talking about the need for water so much as having excess water. Some species simply do not like standing water or just what they perceive as too much water. In some places, this is a notable problem. Rootstock can reduce this and in some cases completely mitigate it as a problem. It's one of the big reasons why citrus trees, for example, are often grown attached to rootstock. The rootstock makes up for the otherwise temperamental nature of some citrus species, and the fact that they really don't like excess water. Others are being used to mitigate problems like, say, salinity, the presence of salt. Others again are trying to more effectively accommodate specific soil conditions in different countries. The next point is perhaps one of the more common reasons, and it's pest protection. There are typically two kinds of pest protection designations. They're basically high resistance and intermediate resistance, high and middle levels, or high and medium if you will. The reason you have two is that, well, low resistance doesn't really provide anything, so it's mostly being disregarded. But the intermediate or medium level and high resistance levels are much more important. In parts of the world, and particularly if we're talking about, say, things like grapevines for making wine, you're going to have to be much more careful. This is something parts of Europe and most of America has learnt very much the hard way. They tried for a very long time to graft grapevines onto rootstock that, well, ultimately proved to be susceptible to certain diseases, and this basically led to the entirety of all of those grapevines having to be not only grafted onto new rootstock, but basically pulled out and destroyed as these pest species or diseases that they were trying to mitigate weren't mitigated. A high resistance basically means that whatever it is you're trying to protect it from should be highly resistant, so basically there's a much higher probability that the plant won't contract that particular disease. They may exhibit some symptoms under particularly high levels of pressure from that pest or disease, but they shouldn't be overly vulnerable to it. The intermediate level isn't so great. Now, if you're not worried about the disease or pest in question, this is actually a pretty good option because you're basically getting protection if it comes up, and it shouldn't come up at a higher concentration or strong level, thereby avoiding the cost and difficulty of having to get intermediate resistance and above that. Rather, you just go with what's only needed, and then you shouldn't even need that level of protection. Finally, we have tree growth, which is perhaps the most well-recognized feature of rootstock use. You have, to make this easy, the example of the apple tree again. Let's start with the basic idea. You have two kinds of rootstock you'll use: seedling rootstock and clonal rootstock. These are the way in which you're going to source your rootstock itself. After that, you're then going to use this, because this should be one of the various varieties of rootstock in use for apples, and you will graft onto it. So to start with, we have seedling rootstock. This is exactly what it sounds like. It's grown from seed. Now, typically speaking, this isn't so great, because you're going to get a variety of characteristics that may not be true to form, meaning you might get different sized, shaped, or coloured apples. They might taste different. The leaves might look different. The branch growth might be different. There are a variety of things that can come up which don't really work so great. So they tend not to be used, barring possibly things like crabapple. For some strange reason, crabapples seem to be rather resilient to most of the possible changes you might otherwise see. A clonal rootstock is, well, basically cuttings. You can have a few different varieties, but for the most part you just think of it that way, as cuttings, and it's easy enough to understand. And it's because they are just that, a clone. Now, in the terms of apple production, you're going to have, say, the M9. Now, M9 is just a classification, a specific classification of rootstock. It's one of the most widely used because it dwarfs the apple tree, and because it makes it smaller, rather than having a massive, great big tree, you have something much more small, compact, and therefore a denser orchard. This is great for orchards because, well, more trees means more apples, means theoretically more income. The other thing is that where it can take apples up to 7 or more years to start fruiting, on rootstock growing well, they'll start bearing fruit within 2 to 4 years. This means that you can up to half the time that you need to wait to get fruit from these trees. And of course, mentioning that they are much smaller. M9 has a second version which is similar to the M9 that we just discussed, but its only real advantage over the other is that it makes fewer burnouts and typically requires more support. Now, there are advantages to this because those burnouts are where you'll basically get suckers growing out of that are purely rootstock and therefore no good for apple trees. But depending on what you want to do, you can either choose more maintenance in the form of the M9 by itself, or the second form of M9, which, although yes, requires less maintenance, does require more infrastructure to support. There are a few other varieties as well, and for the most part we'll just skip through a lot of the details and naming but give you an overview of what they do. The Geneva 11, or the G11, helps increase vigor, and as a result you get better yield. But it does have certain vulnerabilities, particularly in regards to blight and collar rot. you have the B9, and these are smaller trees, anywhere between 1/4 and roughly 1/3 the size of others. They do, however, need to be supported much more. However, although they need more support and they are much smaller, they're very cold hardy, which means that you can grow apple trees in areas that would otherwise be, let's say, unsuitable, particularly due to cold. We then have the medium-sized trees, and these are generally going to be freestanding. What's particularly useful with, say, the M7 is that it's really well suited to rocky soils. That soil that's shallow and doesn't really have a lot of water that'll hang around for very long. It doesn't grow very big, but it does take longer to bear fruit. But as mentioned, particularly in terms of its ability to grow in places that are very inhospitable, it's a good option. We then have the MM106, and this is somewhat vigorous in its growth, meaning it's quite large, but it's not that big overall, at about 3 to 4 meters, which means it's not that much different to the medium M7. It also has a similar time frame to produce fruit. However, unlike the others, these will anchor themselves better to the ground and won't produce suckers, but they do show some of the same issues with regards to, say, collar rot or blight, but they aren't anywhere near as vulnerable to woolly aphids. However, the problem with it is very simple. It doesn't cope well with wet soils, and this is a perhaps major issue with a lot of these rootstocks. They all come with a variety of merits and demerits. As we mentioned, most of them really only have advantages, but they have some minor disadvantages. The M111 is perhaps a better example of this, as it grows larger at roughly 4 to 6 meters in size, but it takes up to 7 years to produce fruit. So it's not a great improvement in terms of the time to produce fruit. But what it does do well is tolerate drought and a wide variety of soils. This means that you don't need to worry near as much about, say, drought or particularly, let's be blunt about this, non-fertile soil. And it doesn't sucker very much, which means all the growth should go into fruit or apple tree, not into something you don't need. But it doesn't have any major protection against any of the other pests, such as collar rot or aphids. And finally, there's a stock that's considered as a subcategory, and it's the interstems. Now, these are sort of related to the M111 or the M106, and this is where you graft another species onto it so that you can grow off a branch of that. Think of something like they would to, say, fruit salad trees, where you have a wide variety of different fruit trees all attached to each other. Well, that's basically what this is used for. One advantage of it is simply that you can reduce the size of the tree overall, because you really are relying primarily on this interstem to provide you with all the support and structure for the apple tree you actually want to grow on the end of these branches. This overall reduces the size and gives you a strong root system that should support its growth, but it doesn't necessarily help as much with sizing. It'll still be a smallish tree, but not as small. As you can see, a rootstock is not just a root or small trunk on which you graft a much larger tree or a more preferred species. Instead, what it does is provide you with a series of advantages, and in some cases disadvantages, on which you can decide what you need and what you want to have for particular kinds of fruit trees. And we have focused on apples in this video, but you can look at all kinds of different species, whether it's stone fruit, nut trees, apples, pears. There's a whole world out there on which these can work, and there's a particularly wide amount of research, particularly when we talk about viticulture or winemaking and vineyards. And you'll find that there are a series of detailed articles linked in the description box below for further reading if you're interested in doing so. Thank you for watching this video. If you found it interesting, consider liking, sharing, and subscribing. And please do post any comments, questions, or suggestions you have below.